Hi, this is Week by Week Essentials Week 1. So this first problem, algebraically speaking, you have different shapes that add up to these different numbers. And what you call this is a system of equations. This is an equation, that's an equation, that's an equation. You use all three in order to come up with an answer for each of the shapes. Now, we can see that triangle plus cylinder is equal to 12. And we're going to use something called substitution, in which we take this value right here, which we know is 12, and substitute it for this triangle and this cylinder. I mean, this is the same thing as saying triangle plus cylinder up here. I mean, it's just replicated into this problem. So now we can find square. Square plus this value 12 is equal to 21. And you know by your algebra rules that in order to get rid of the 12 you have to subtract it from both sides. So now we get square is equal to square is equal to 9. Okay. See down here, hey, here's a square. Another substitution that we can do. So triangle plus 9 will give us 14. Do the same thing as with the 12, subtract 9, and you get triangles equal to 5. And lastly, to get cylinder, of course, I mean, there's two ways you can do it. You can substitute your triangle and square into your top problem, or you can just look at this problem down here and substitute triangle in. So I'm just going to do this one. 5 plus cylinder is equal to 12. Subtract the 5 and you get 7. So your answers are 5, 9, and 7 for each of the shapes. That's called substitution in algebra. Let me erase this. Okay. The next problem, investigate data. It says John's test grades were 76, 82, 95, 82, 78, 96, and 91. Now, it uses the term measure of central tendency, and that's basically a number that represents the center or middle of a set of data. So, essentially what they're asking in this problem is it best to use mean or mode? These two things find like the middle value of the whole. No, not mean and mode. Sorry, it's median. Median, of course, means middle. So we're trying to find which is more accurate, the mean or the median. And so what we can do. Well, actually, the problem is trying to raise John's test grade up to its highest average, and we're going to use these two methods to find which has the higher average. So basically for mean, you know that you just add all the numbers up and you get some number, and you divide by how many numbers there are. In this case, it's 7. So when you add all of those up and divide by 7, then you get your mean as 85.7. Your median, this is kind of tricky because before you mark out your numbers on either side, you have to put them in order from least to greatest. So it's going to be 76, 78, 82, 82, 91, 95, and 96. Then you can start marking out. So just keep going, alternating sides. Okay. Okay, so you get 82. Now, of course, 85.7 is the highest, so that would be your answer. Okay, next is geometry rules. Not much to this. You have a circle, and you're asked how many three-dimensional shapes you can make out of this. Three-dimensional basically means you have a length, a width, and a height. Well, in this case, the length and width would be the area of the base here times its height, or whatever it is. So the only shape, like all the natural shapes that you should think of are, well, you can make a triangle here to make a cone, or you can just add a circle on top, make a cylinder. And it only asked for two, so that's your answer. Cone and cylinder. Now for area of both of these, I don't know if you need to know this, but cylinder, here's the height, here's the radius. Basically what you have to do is get the area of this circle up here, so that's going to be pi r squared, that's the area of the circle, times your h. That'll give you area. And for a cone, I'm pretty sure it's, you gotta find the base, which is pi r squared again, times, I think it's 1/3 the height. I'm not really sure, I need to check up on that, but that's basically what you do for area of these shapes with a circular base. Now when I say base, I'm referring to this right here. This is what they call the base. Some people say base times height, some people say like bottom times height, I don't know. But when they're referring to base, it's like the bottom of it. An example for a cube, the base would be down here. That's the base. Wherever it's sitting, if you think of it sitting on a table, wherever it sits on the table. Okay. So next question, Mathmania. This one's a little bit more complicated. It says, how would you prove that there is no largest prime number? And this takes a while to think about, but basically what I came up with was this. Okay, let's see. Let's think of a prime number. Let's say 113. Okay, nothing can be divided into it. That's what prime means. It's only divisible by itself and 1. So this would be a prime number. And the way I think of it is, if you think you add a 0 in between the 1 and the 1, then essentially you're going to come up with another prime number. And I mean, if you try to divide anything into this number, it's basically not going to divide, simply because this 0 has no significance in changing its prime value. So I mean, I can just keep adding zeros infinitely. This is the sign for infinity, by the way, just a little sideways 8. I could just keep adding zeros, and this number will still stay prime. So that's my theory of how there's infinite prime numbers. That 0 keeps the numbers prime the same. Okay. Now, let's see. Solve it. They're visiting a hardware store, and these guys bought some things, okay? And first thing I notice in this is there is no meaning to these sentences are not written right. That's the first thing I see. He says, bought for bought for 50 cents. Now that doesn't make sense to me, because for what? There's got to be something. Is it books? Is it CDs? Whatever it is. Now, since you look at the next thing somebody bought,